Hello, my dear friends. How are you all? I hope you all are fine. So, you are very welcome in our lecture number 4 of statistics. Okay, so I hope you will enjoy this lecture, my dear friends. Yes, so now let's start. So today we are going to discuss frequency polygon. What is? Yes, today we are going to discuss about frequency polygon. So, a frequency polygon is almost identical to a histogram. It is almost identical to a histogram, which is used to compare sets of data or to display a cumulative frequency distributions. Okay, it uses a line graph to represent quantitative data, now if the midpoint of each rectangle in a histogram are joined, okay, if we join the midpoint of each rectangle of the histogram, okay, by line segment, then the figure formed will be a frequency polygon, and it can be drawn without histogram need midpoints of class intervals. Okay, now here you can see, let's suppose we have a histogram between number of students and heights. Okay, so this is the histogram. Now we have to find the midpoints of these width. Okay, midpoint of these width. So basically it is what? Basically it is the midpoint of class intervals. It is midpoint of class intervals, or we can say class marks. Okay, I hope you get this point. Now we are joining these midpoints. Okay, then we get a figure like, so that figure is called, frequency polygons. What is? Yes, frequency polygons. I hope, my dear friend, you understand these things. Yes, so now, my dear friends, here is now steps to draw frequency polygon. Okay, steps to draw frequency polygons. Okay, so first of all, we have to choose the class interval and mark the values on the horizontal axis. Okay, now mark the mid values of each interval on the horizontal axis. Got it? Now mark the frequency of the class on the vertical axis. Now corresponding to the frequency of each class interval, mark a point at the height in the middle of the class interval and connect these points using the line segment. Then the obtained representation is the frequency polygons. What is? Yeah, frequency polygons. I hope you understand these things, my dear friend. Yes. Now let's see how to find the midpoint of the class interval. Okay, so midpoint of the class interval is called the class mark. What is class mark? So how we can find it? So the formula is upper limit plus lower limit divided by 2. This is very easy. Upper limit plus lower limit and divided by 2. So we get what? We get the class marks. I hope you get this point. Yes, so now let's see the problems based on the frequency polygons. Okay, I hope you get this point. Now, my dear friends, so the question number 1 here is, in a batch of 400 students, the height of students is given in the following table. Okay, now represent it through a frequency polygon. Through what? Yes, through a frequency polygon. Now, if you observe this, here we have a class interval like this. So this is what? This is height in centimeter, and in this column here we have the number of students, or we can say it is frequency. So we can say that there are total 74 students which having the height in the range of 140 to 150. Okay, and we can say there are total 163 students which having the height between 150 to 160. Okay, and so on. Okay, so if we add these frequencies, here we get, yes, total 400, and we have 400 students in the question. Now we have to represent it. So let's see the steps. The heights are represented on the horizontal axis on a suitable scale. Okay, now the number of students is represented on the vertical axis on a suitable scale as shown. Okay, now rectangular bar of width equal to the class size and the length on the bars corresponding to the frequency of the class interval is drawn. Okay, now first of all here is we have to find the class marks. We have to find the class marks. Okay, so now here you can see that here is, let's suppose we are doing a column. So this is what, this is class marks. So we know that class marks is what? Upper limit plus lower limit divided by 2. So if we add 140, 150 plus 140, okay, and we have to divide it by 2. Here we get 145. What is 145? Okay, now if we want to find the class marks of this interval, so this is what, 150 plus 160, okay, and it is divided by 2. So here we get 155. Similarly, this will become 165 and this will become like, yes, 175. So this is what, this is the class mark. Now here you can see in this diagram, here is on the horizontal side, on the x-axis we are taking the heights and on the y-axis we are taking the number of students. Okay, and we are representing the class interval, and we have to also represent the class marks also. Here is, this is 145, 155, 165 and 175. This is what, this is the class mark. Okay, now we have to draw the histogram like this, so you can see in the figure. Got it? Yes. So we have to plot the midpoints of these rectangles. Okay, of these rectangles, these are what, these are the class marks, means these are opposite to the, yeah, these class marks. Okay, I hope you get this point. Now we have to join these points, we have to join these points. Okay, so we get a frequency polygon, we get a frequency polygon. I hope my dear friend you understand these things. Yes, so now let's move on to the next question. Here is, yes, the following table gives the distribution of students of two sections according to the marks obtained by them, according to the marks obtained by them. Okay, got it? Yes. Now here is, you can see in the section 1, here is we have the marks, okay, and here we have the frequency. Okay, it means we can say that there are total 3 students having the marks between 0 to 10. There are total 9 students having the marks 10 to 20. There are total 17 students having the marks 20 to 30. Okay, and so on. Similarly, in the section B, we have the marks and frequency. It means we can say that there are 5 students having the marks between 0 to 10. There are 19 students having the marks 10 to 20. There are 15 students having the marks 20 to 30. And there are 10 students having the marks 30 to 40. And there are 1 student having the marks 40 to 50. Got it? Now we have to make the, here you can see, represent the marks of the students on both the section on the same graph by 2 frequency polygons, okay, and from the 2 polygons compare the performance of the 2 sections, and we have to compare the performance of these sections, section A and section B. Okay, yes, so now my dear friends, first of all, here is, to make frequency polygon, first of all we have to plot the class marks. Okay, so now here is, to make frequency polygon, okay, to make frequency polygon we plot class marks, and frequency. Okay, and frequency, we have to draw the graph between class marks and frequency. Okay, so what is the formula of class marks, how we can find? So class marks is equals to, we know that this is upper class limit class limit plus here is this is lower class limit. What is lower class limit? And it is divided by 2. Okay, so this is the formula. Now with the help of this formula, let's find that. Yes, so now here is, let's find that. So here is, you can see we have a class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So these class intervals are what? These class intervals is this is continuous class intervals. Okay, and here is, you can see the class size is also same. Here is 10 minus 0 is 10, minus 0 is 10, 20 minus 10 is 10, 30 minus 20 is 10. So this is constant. Now we have to find the class mark. Here you can see that we know that this is 0 plus 10 divided by 2. So this is equals to 5. Here is 10 plus 20 divided by 2. Here we get 15. Okay, and 20 plus 30 divided by 2. So this is equals to 25. This is 30 plus 40 divided by 2. Here we get 35. And here is 40 plus 50 divided by 2. So we get 45. So now this is what? This is the class mark. This is the class mark. With the help of these class marks, we can easily draw the frequency polygon. Now we have the frequency of fraction A 3, 9, 17, 20, and 12, and 9. Okay, and frequency of fraction B 5, 19, 15, 10, and 1. Okay, so we have the frequency of fraction A and frequency of fraction B. Got it? Now first of all, we have to calculating point where frequency is equals to 0. Okay, it means we have to find the starting points and the ending points in the graph. Okay, how we can find it? Here you can see that. Now here we know that the difference is what? The difference is this is equal. Now here is the difference between the class marks is what? Here you can see 15 minus 5 is what? This is 10. Similarly 25 minus 15, this is 10. 35 minus 25, this is also 10. 45 minus 35, this is also 10. So the common difference is what? Here we can write 15 minus 5, this is equals to 10. Now for finding the first point, for first point we have to subtract 10 from the minimum class marks. Okay, what is the minimum? This is 5. So here we can see that, here we can write it as 5 minus 10 will be minus 5. This will be what? Minus 5. Now for second point, we have to add the difference in the highest class mark. So this is the highest class mark 45. So we have to add 10 in the 45. So here we get, so this will become 45 plus 10, this will become 55. Okay, yeah, so here is, so we have to plot, we plot points here. So these are the points where frequency is 0. So we are calculating the points where frequency is 0. So here we can write minus 5 comma 0 and 55 comma 0. So this is the starting points and this is the ending points. Okay, now let's draw the frequency polygon. So here you can see in this diagram we have two lines. This line represents the section A and this line represents the section B. Here we have class mark 5, 15, 25, 35, 45. Okay, and we have frequency A which is 3, 9, 17, 12, 9, and the frequency of section B which is 5, 19, 15, 10, and 1. Now first of all we have to plot the points minus 5 comma 0. Okay, so here you can see in the graph minus 5 comma 0 is on the minus x-axis. So here is, this is minus 5 comma 0. Now we have to start for the section A. So here is the points is what? 5 comma 3, because 5 is what? 5 is the marks, and we know that marks are plotted on the x-axis, and number of students are lie on the y-axis. So here this is frequency which is lie on the y-axis. Now here is we have to plot 5 comma 3. It means 5 on the x-axis and 3 on the y-axis. So here you can see that this point represents the 5 comma 3. Okay, and now the next point is 15 comma 9. It means 15 on the x-axis and 9 on the y-axis. So here you can see this is what? This is 15 comma 9. Got it? And the next one is 25 comma 17. It means 25 on the, here is 25 on the x-axis and 17 on the y-axis. So here we get like the point. Here you can see this is the point 25 comma 17. Got it? And 35 comma 12. 35 on the x-axis and 12 on the 12 on the y-axis. So here we get like this. We get this point. So this is 35 comma 12. Similarly 45 comma 9. So this point is represent the 45 comma 9. So this is what? Now if we join these, here we get what? Here we get the section A graph. Here we get the section A graph. Now we have to plot the section B graph. So here is, you can see that the points are 5 comma 5. 5 is on the, this 5 is on the x-axis, and this 5 means frequency 5 is on the y-axis. So here we get this point like this. Okay, similarly 15 comma 19. Okay, so we get the point 15 comma 19. Here is 25 comma 15. Okay, so you can see 25 comma 15. Here is 25 comma 15. Okay, and 35 comma 10. So this is, you can see 35 comma 10. 45 comma 1. So you can see 45 comma 1, and the last is 55 comma 0. So this is the first point, this is the last point. So now my dear friends, so these two graphs are what? These two graphs are represent, this is section A and this is represent section B. Okay, got it? So now you can see in this, here you can see section A is to the right of the section B. Here you can see that this is what? This part is right of the section B. So the marks is 35 and 45. These marks are the highest marks. These marks are what? Highest marks. So here you can see there are 12 students which having the 35 marks, and there are 9 students which having the 45 marks. Okay, it means here you can see, and on the other hand there are 10 students which having the 35 marks, and there are 1 student which having the 45 marks, like this. It means we can say that the performance of section A students is high as compared to the section B. So we can say that since section A is to the right of section B, is to the right of section B. Okay, so more students of section A has higher marks, I hope my dear friend you understand these things. So this is what? This is the answer of this question. Yes, so now let's move on to the next question here, which is the runs scored by two teams A and B on the first 60 balls in a cricket match are given as. Got it? Now here you can see that team A scored 2 in the first 1 to 6 balls, and team B scored 5 on the first 1 to 6 balls. Okay, and team A scored 1 run. Okay, team A scored 1 runs between the balls 7 to 12. Similarly, team B scored 6 runs. Okay, and so on and so on. Here you can see that. Okay, I hope you understand these things. Yes, so now here we have to represent the data of both the teams on the same graph by frequency polygons. By what? By frequency polygon. So first of all, now here you can see, if you see that these class intervals are what? These class intervals are not continuous. Are not continuous. Okay, you can see this is 1 to 6, 7 to 12, 13 to 18. Okay, so first of all, we have to make the continuous class intervals. Okay, so to draw the frequency polygon, first of all, we have to make what? We have to make the continuous data. We have to make the continuous data. So to draw frequency polygons, we have to make the continuous data or continuous class intervals. Continuous class intervals. Okay. Now here we observe that the gap is what? The gap is 6 and 7. Between the 6 and 7, the gap is what? This is 1. Okay, if you subtract 7 minus 6, this is 1. If you subtract 17 minus 12, we get 1. If you subtract 19 minus 18, we get 1. So here we can write, if you observe this, we observe that the gap is 7 to 6 is 1. Okay, 7 minus 6 is 1. So here is, we have gap upon 2. This is equals to 1 upon 2. It means 0.5. It means we have to add 0.5 to each upper limit and subtract 0.5 from each lower class limit. Okay, so to make the class interval continuous. Okay, so here is, we add 0.5 to each upper class limit and subtract 0.5 from each lower class limit. Okay, so subtract 0.5 from each lower class limit to make class interval continuous. Okay, now let's do that. Here is, now if you observe this will become 0.5 to 6.5. This will become 6.5 to 12.5, and this will become 12.5 to 18.5. So after adding the 0.5 in each upper class limit and after subtracting the 0.5 from each lower class limit, so we get the continuous class interval. We get what? Continuous class interval. Now here is, now we have to make the class marks. We have to find the class marks. Okay, so here is, you can see that we know that class marks is what? Upper limit plus lower limit divided by 2. Okay, so if we add these two limits, 0.5 plus 6.5 divided by 2, here we get 3.5. We get what? 3.5. Similarly, we get 9.5. Here we get 15.5. Okay, and here we get 21.5. Here we get 27.5. Okay, and this is 33.5. This is 39.5. This is 45.5. Okay, this is 51.5, and this one is 57.5. I hope you understand these things, my dear friends. So this is what? This is the class marks, and we know that this is team A and this is team B. Okay, I hope you understand these things, my dear friends. So now first of all, now we have to calculating the points where frequency is 0. It means we have to find the starting points and we have to find the ending points. Okay, so for finding this, first of all we have to find the difference between the two consecutive class marks. Okay, so here is you can see that if we subtract 9.5 to 3.5, here we get 6. It means 6 is what? 6 is the common difference. If we subtract 15.5 to 9.5, again we get 6. Okay, so I hope you understand these things, my dear friends. So now here we can write calculating points where frequency is 0. Okay, so here first of all the difference is what? The common difference. We can say that the difference is equal to 9.5 minus 3.5. Here we get 6. Okay, so the first point will be, this will be 3.5 minus 6. This is equals to minus 2.5. This point is on x-axis, and the last point will be, so here is, this is 57.5 plus 6, and this will be what? 63.5. So we plot the points. Okay, and here we know that frequency is 0, so the points will be minus 2.5 comma 0. This is first point, and the last point is 63.5 comma 0. Okay, now let's draw the diagram. Here we have class marks, team A runs and team B runs. Okay, so here you can see that there are two lines. This line represents the section A. Okay, this line represents the section A and this line represents the section B. Got it? Now first of all we have to plot the first point, which is minus 2.5 comma 0. So this is the starting points of these two graphs. Okay, so then we have to plot 3.5 comma 2. It means 3.5 is on the x-axis, and here is 2 is on the y-axis. This is the frequency. Okay, this is the frequency. Okay, yes. So now here is you can see that, so 3.5 comma 2 represent here. Now 9.5 comma 1, here you can see this point is 9.5 comma 1. Now 15.5 comma 8, you can see 15.5 comma 8. 21.5 comma 9, here you can see 21.5 comma 9. Okay, 27.5 comma 4, 27.5 comma 4. This is 33.5 comma 5, 33. Here you can see this is 33.5 comma 5. This is 39.5 comma 6. Okay, this is 45.5 comma 10. Okay, and the next one is 51.5 comma 6, and the last one is 57.5 comma 2, and the final endpoint is, yes, you know that this is 63.5 comma 0. So this is the frequency polygon of team A. Okay, now if you observe this, the blue line, this is the frequency polygon of team B. Here you can see that first of all we have to plot the starting point, which is minus 2.5 comma 0, and then the next one is 3.5 comma 5. We have to take these class marks and team B runs. Okay, so 3.5 comma 5, here will be, you can see, this is the first point, this is the second point, third point, 5th, 6th, 7th, 8th, 9th, 10th, 11th. Okay, and the last is 13. And if we join this point, here we get the frequency polygon of team B. I hope you understand these things, my dear friends. So this is what? This is the, yeah, frequency polygons. Okay. Yes. So now let's move on to the next question, which is, here you can see a random survey of the number of children of various age groups playing in a park was found as follows. Here you can see that we have the ages in years and we have number of children. It means we can say there are total five is a number of children, okay, which having the age between 1 to 2. There are total three number of children which having the age 2 to 3, okay, and so on and so on. Now draw a histogram to represent the above data, got it? Now here you can see that here the data has class interval of varying width. Okay, here the widths are varying. Okay, here you can see that the class interval is continuous, but here the width is varying. Here you can see that the width of this class interval is 2 minus 1, which is 1. The width of this 3 minus 2, which is again 1. Now 5 minus 3, this is 2. 7 minus 5, this is 2. 10 minus 7, this is 3. 15 minus 13, which is 5. And 17 minus 15, which is 2. So you can see that here is width is what? Here width is varying. Okay. Okay. So the width of the class interval in the given data is varying. So we know that the area of rectangle is proportional to the frequencies in the histogram. Area of rectangle proportional to the frequencies in the histogram. So the proportional of the children per year can be calculated as, here you can see that, here you can see, first of all we have to calculate the adjusted frequency. Okay, so here is the data has class interval. The data has class intervals of varying width. Okay, so we calculate adjusted frequency. Got it? So how to find adjusted frequency? There is a formula like adjusted frequency is equals to, here is frequency into, okay, the corresponding frequency into required size of interval, means minimum size of interval, or we can say that least class width. Okay, so frequency into required size of interval. Okay, it is divided by current size of interval. It is divided by current, or we can say current width of interval. Current size of interval. Okay, so this is the formula to find the adjusted frequency. So here is required size of interval is what? Required size of interval is equals to, here you can see that minimum size of interval. So this is what? This is 2 minus 1, which is 1. Here you can see this is the first interval, 2 minus 1, which is 1. So this is the least class width. Okay, this is what? This is the least class width. Okay, now let's find the adjusted frequency. Here you can see that we have the intervals, which is ages in years. Okay, and we have number of children. This is frequency. Okay, this is current frequency. Okay, and here is current interval. This is what? 2 minus 1, this is 1. 3 minus 2, this is 1. Okay, similar and so on. Okay, and here is adjusted frequency. This is what this is. Here you can see that. Now we know that this is frequency, means current frequency. This is 5 into required size of interval, means minimum size of interval, which is 1. So 5 into 1 divided by current size of interval, which is 1. So this is 5 into 1 divided by 1, we get 5. Now here is 3, which is current frequency. Okay, into minimum frequency, minimum size interval, this is 1, divided by, divided by current size of interval, this is 1. Here we get 3. Similarly, here is current frequency, this is 6, into minimum size of interval, which is 1. We know that this is constant. This is constant in every adjusted frequency. Okay, and it is divided by current interval, which is 2. Current size of interval, which is 2. So after solving this, we get 3. Similarly and so on. Here we get 3, 6, 3, 2, 2. So this is what this is adjusted frequency. This is different from the original frequency. This is different from the original frequency. This is just because of the varying class size. Okay, understand, my dear friend? Yes. So now here we are going to represent this. You can see this is what, this is the histogram. Okay, so here this is the representation with adjusted frequency. This is the data with adjusted frequency, and this is the representation of this table. Okay, here is the class interval 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. Okay, and here is, you can see there are 5. The frequency is 5 in between 1 to 2. Here is, we can write 5. Here this is 3. This is 3. This is 6, 5 to 7. This is again 3. This is 2, and this is 2. I hope, my dear friend, you understand these things. So this is what, this is the histogram. Yes. So the next question here is, you can see 100 surnames were randomly picked up from a local telephone directory, and a frequency distribution of the number of letters in the English alphabet in the surnames was found as follows. Here you can see that there are 6 surnames which having the letters between 1 to 4. Okay, and similarly there are 30 surnames which having the letters between 4 to 6. Okay, I hope, which having the number of letters in English alphabets. Okay, and so on. Got it? Now here is, first of all, we have to draw a histogram to depict the given information. Histogram to depict the given information. Got it? Now again, if you observe this table, here you observe this, that again we have varying class width. Okay, so again the data has class interval of varying width. Here you can see that here 4 minus 1 is what, this is 3. Okay, and here 6 minus 4, this is 2. 8 minus 6, this is 2. 12 minus 8, this is 4. 20 minus 12, this is, the class size is 8. So you can see that there are again different class size. There is not constant. Okay, so first of all we have to find the adjusted frequency. Again we have to find the adjusted frequency. Okay, here you can see that we have number of letters, this is the class intervals. Okay, and we have number of surnames, this is frequency. So the current interval is like, we have to find the current size of this interval. So 4 minus 1, this is 3. This is 2, 2, 4, and 8. Okay, and now we have to find the adjusted frequency. So what is adjusted frequency? We know that this is frequency, means current frequency into minimum size of interval. Now here you can observe this, the minimum size of interval is what? 6 minus 4, this is 2. This is what? This is the minimum size of interval. Okay, so 6 into 2 divided by, current size of interval. So this is 3. After solving this, here we get 4. Similarly in the second row, here is the adjusted frequency is 30 into 30 is the yes current frequency. Okay, into 2 is least class width, this is 2 divided by current size interval. Okay, yes, this is 2. So after solving this, here we get 30. Similarly, here we get 44, 8 and 1. 44, 8 and 1. So this is the adjusted frequency. Now with the help of this data, we have number of liters and we have adjusted frequency. Okay, with the help of this we are going to draw the histogram. Here on the x-axis we are taking the number of letters, and on the y-axis we are taking the proportional of the surnames per 2 liters intervals. Got it? So between 1 to 4 there are 4 surnames. Between 4 to 6 we have 30. Similarly, we have between 6 to 8 we have 44. Between 8 to 12 we have 8. And between 12 to 20 we have 1. We have what? We have 1. Got it? Now the next part of this question here is saying that write the class interval in which the maximum number of surnames lie. Okay, if you observe this table, and graph as well, so you will observe that there are 44 surnames in the range of 6 to 8. So we can say that here we can say maximum number of surnames lies is 6 to 8 as it has 44 surnames. It has 44 surnames in it. Okay, my dear friends, I hope you understand these things. So now this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.